So this is 11.4. We're adding and subtracting rational expressions. And basically, you're going to treat this just like a regular fraction. So in regular fractions, when you add and subtract, you have to have common denominators. Same thing with rational expressions. Notice how this is the same denominator. So I can just go ahead and add them. I can put them over one denominator. And since they are like terms, I can add them together. Nothing can be reduced, and they're both monomials, so I can reduce them. So that's my answer. This one, same thing. It's a binomial, but it's the same denominator. So I can go ahead and write 3x plus x. Since they are like terms, I can combine them. And I can't reduce because here's a binomial, here's a monomial. I can't reduce a binomial with a monomial. Go ahead and try the next one. Okay, check your answer. Alright, so again here are like denominators, but here we are subtracting. And when you subtract, yes, you're still going to put them over one denominator because they are the same denominator. But you have to remember that that minus sign has to be distributed to both numbers over here. So you need to make sure that you distribute that negative to the 4x and the 3. Because they're both being subtracted, not just one. Now I can combine my like terms. So 7x minus 4x is 3x. 5 minus 3 is 2. And then on the bottom, my trinomial can be factored. And I need to factor because if I can cancel anything out, I won't know unless it's factored out because I can't cancel a binomial with a trinomial. They have to be the same. So I'm going to go ahead and factor it out. So this is the same on top, 3x plus 2. But on the bottom, I'm going to have my 2 parentheses. Signs are going to be different. Factors of 3x squared are 3x and x. And factors of 2 are 2 and 1. So let's check. 2x minus 3x gives me a negative 1x. So I know I did it right. And at this point, I want to find my... Oh, we won't do that with these actually. So in any case, now I can reduce, right? I can simplify. So these can cancel because it's a whole binomial. I'm left with just a 1. And that leaves me with 1 over x minus 1. Go ahead and try the next one. Okay, so this one had a GCF. So I went ahead and took out, so after we combine it, remember to distribute that negative, I went ahead and took out the GCF here, and they can cancel, and I'm left with just the binomials. Okay, so what if the denominators are different? Well, in this case, it's simple because they're just monomials. So I just look at the number, and I say, what would both 2 and 6 go into? What would be my common denominator here? And it would be 6. As for the variable, I take the biggest of the variables. So the biggest one is x squared because x can go into x squared, but x squared can't go into x because it's smaller. So it would be x squared. So now, what did I have to multiply 6x by to get 6x squared? Well, I had to multiply by x. So I have to do the same thing on the top. Shoot, I don't know what happened there. Okay, and then what did I have to multiply 2x squared by to get 6x squared? Well, from 2 to 6 I had to multiply by 3, but the x squareds didn't change. So I'm just going to multiply by 3. Now my denominators are the same, and I can put everything over one denominator. So I end up with 5x plus 9 over 6x squared, and there's nothing else I can do there because I can't reduce a binomial with a monomial, and these are not like terms, so I can't combine them. Go ahead and try the next one. So go ahead and check your answer. Okay, let's look at the next one. So these are different denominators, but they are binomials. And basically with a binomial, since we don't know what the d stands for, we can't actually find out what they both go into. So when we make our common denominators, we just put both binomials. So it would be d minus 1, d plus 2. d minus 1, d plus 2. Okay. So how did I go from d minus 1 to d minus 1, d plus 2? Well, since I started out with just a d minus 1, what I multiplied by was d plus 2. That's how I got both things. So now I do the same thing to the top. And then on this one, I start out with d plus 2, so I had to multiply by d minus 1. So I'm going to do the same thing on the top. So now we can put it all over one denominator. And I'm going to distribute this. Minus, and then I'm going to distribute this, but I'm going to put in a parentheses because I need to distribute that minus sign as well. So now I have 3d plus 6 minus 2d plus 2, because I distributed this negative, over d minus 1d plus 2. And I can combine my like terms, so 3d minus 2d is d, and 6 plus 2 is 8. I can't reduce anything because none of the binomials match. Okay, go ahead and try the next problem. Okay, so here's your answer. Go ahead and check that. Okay, so the last problem is called a special problem because we have opposite factors here. See, this n is negative, this n is positive. This one is positive, this one is negative. So in order to find our common denominator, simply, all we have to do is factor out a negative 1. Because if I factor out a negative 1, that'll make this one negative and this n positive. And in that case, I will now have common denominators if I move this negative 1 up. So now I have a negative 1 and a positive n minus 1. Here again, n minus 1, same denominator. So I can put them all over 1. And then again, if I factor out a negative here, I have opposites. So I'm going to factor out a negative, and that'll leave me with a positive n and a negative 1. And on the bottom, I already had a positive n and a negative 1. So now I can cancel these binomials, and my answer is just negative 1. But the point of this problem really was to show you that if you have opposites, you can always factor out a negative 1 to make them the same.